Mark Strassman, reporter with Etopia Media Medical News Network. We're about to speak to Yulun Wang, who's the founder and CEO of InTouch Health, Inc. in Santa Barbara, California. Welcome to Etopia Media Medical News Network.
Thank you, Mark.
Why don't you tell us just a little bit about your background and how it led you to found InTouch Health? And maybe before you start, you can introduce that entity on your right there.
Great, sure. This is what we call RP-6. RP stands for Remote Presence. This is really the world's first remote presence robot. On the screen here we have Juan Sanchez, who works with me at InTouch Health. And my own background is I have a doctorate in robotics, in electrical engineering, specialized in robotics. And I previously started a company called Computer Motion, which started the field of surgical robots. So I've been in the medical field for up to 15 years, so I've been in a lot of hospitals. And in starting InTouch Health, what I was able to do is to think a lot about what's the biggest problem that we have in the healthcare system today. And it's really not what one might think of in terms of, say, solving cancer or heart disease, which are significant problems and will be great when we finally solve them, as we are doing. But what's happening is we're pushing off all of these diseases and which make people die, is we are extending people's lives, and therefore the requirement for health care is going up astronomically, and our healthcare professional pool, the doctors, the nurses, etc., are becoming more and more of a limited resource. And so what InTouch Health is doing is using remote presence through this RP-6 in order to enable these healthcare experts, these nurses and physicians, to be in two places at once. And what robotics can do is they can allow the projection of human perception and dexterity to a remote location, and therefore by coupling this with nurses and doctors, we allow those people to project themselves into the patient's bedside when they otherwise can't get there. When they're either at another hospital or their clinic or even at home in the evening, they can be instantly available to help take care of their patients from these other locations.
Okay, so the point essentially is to remotely project the expertise and presence of scarce healthcare resources and expertise to the locations where they're needed without requiring the holders of the expertise to sit on the 101 and the 405 freeway and be blocked in traffic when they're trying to go from Cedars-Sinai to UCLA Medical Center or up to UC Santa Barbara or wherever they're trying to travel. Cut out the travel time for the doctors.
Exactly, and if you've driven to UCLA, as I have many times, that last 2 blocks can take you half an hour, and then parking another half an hour. So to get there, even if you only live a few miles away, you can be there instantly, have a 3 to 5 minute interaction with the patient, which is typically all it takes to assess the situation, talk to the patient, understand what's going on, prescribe a change perhaps in their care plan, and then allow that process to move forward.
So again, to emphasize that, it's essentially the icing on the cake without all the cake. You don't have to drive, park, find the place, check in, do all of those things. You just be there at the bedside. You go to, so you can be in a bedside in New York, in Santa Barbara, in Rio de Janeiro within 10 minutes.
You're taking out the overhead. Right. And as an example, what you just mentioned, we've just shipped a control station to a Dr. Lima in Lisbon, Portugal. He does quite a bit of work with the Detroit Medical Center, the rehabilitation hospital, which is our largest customer currently. He has a unique method of using stem cell implantation into spinal cord injury patients, and he'll operate on these American patients over in Portugal, and then they come back for rehabilitation in the rehab hospital at Detroit Medical Center, and this will allow him to continue interacting with his patients and dialogue with them and round on them over the 6 to 9 month rehabilitation process that they go through.
Without obviously flying from Lisbon to New York to Detroit and so on every time he has to see one of them.
Exactly, and as you know, that just doesn't happen, or you can speculate that just doesn't happen very often, if ever.
Okay, how about the use of this system for getting even general practitioners or specialists into remote and or underserved areas in the United States or elsewhere?
Most definitely. The way the healthcare system is evolving is are becoming these centers of excellences. You have the world's expert in this or the world's expert in that, and they're very few and far between. And to be able to leverage on them into the rural areas or even the underserved areas within a metropolitan area will be a great benefit.
Speaking of cost benefit, talk a little bit about the pricing of these systems. How much does it cost for the base unit that would be at the doctor's residence or office? How much does it cost to provide these units for the hospitals and other healthcare settings that use them?
Yeah, so what we're doing now is the RP-6, which is what you see right here. We are renting them to the hospitals for $4,000 a month. And then the control station, which is the computer system by which the physician beams into the robot from a remote location, those are being sold for $5,000 each.
And how does that amortize out for the hospitals in terms of the cost benefit?
Well, it amortizes very, very well. If you think about one of our big applications is enabling critical care specialists to beam into the hospital ICU. The ICU consumes about a third of the cost of the hospital dollar, and the issues related to morbidity and mortality, for example, complications which happen to the patient in the ICU and death that occurs in the ICU, and additionally throughput in the ICU are significant economic drivers of the hospital's performance. You can imagine morbidity, a complication that happens because of a delayed response by the physician. It's that 80-20 rule. 20% of the patients consume 80% of the costs. Those 80% of those costs are significant, often because the physician was not able to get over there soon enough to stop an adverse event from happening, and so it happens. The patient becomes very ill and has to spend many more days in the ICU, which otherwise they might not be. With regards to throughput, a hospital has surgery units. Those patients come out of surgery, they go into the ICU, and there's a limited number of beds. And it's like let's think of it like a pipeline or a manufacturing plant. If there aren't beds open there, it stops the whole chain of events from happening. You can't do more surgeries because you don't have enough ICU beds. And to be able to move those patients out of the ICU beds into the patient's ward helps the whole flow through, and so the economics are significant in terms of return on investment for the hospital.
So the idea is that by having more presence more of the time in the ICU, the process can be speeded up or made more efficient, so that the interventions leveraged by your technology allows cost savings for the hospital as well as benefits for the patients.
Exactly.
Okay. Now, do these machines sit in the ICU all the time, and the operator can rotate them to look at different patients? What's the operational capability of the mobility of this unit?
Well, the mobility of the unit is just like our human mobility. It has a very unique platform where it's riding on these balls instead of wheels, and the balls are driven with a interesting mechanism which allows me to move the robot in any direction at any time. So it's like what your legs are able to do. Unlike what a car can do. Cars have wheels instead of balls, and so, for example, you need to parallel park. But if you were a person walking in the line, you can just scoot in sideways. So the mobility is actually quite good on this device. And with regards to where it stays, when it's not being used, it just backs up next to any wall plug. You plug it in, and it just stays there until someone logs on and uses it. And that's usually, like in the ICU, it's probably over against the wall in the ICU, plugged in. Like at UCLA, it's plugged in against the wall in the neuro ICU unit. And when doctors Vespa or Martin log in, they can wheel right out, and it's about a 10-foot walk or roll to the first patient, and then you can go down that 10-bed ward just driving it down.
Now, is it connected by a really long extension cord, or does it have batteries? How does it get its power?
It actually has 2 large batteries, and so it can run about 6 hours between charges, and it's driven by a wireless network. It's called it's Wi-Fi network, which allows the system to stay mobile and untethered while enabling the communication of video and audio and other information back and forth between the physician's location.
Does it require a special installation of Wi-Fi in the hospital setting, or does it just use 802.11b in a standard format?
It just uses 802.11b, and which is, as you know, the dominant form of Wi-Fi today, and hospitals today either have 802.11b, many of them do, and if they don't, all the hospitals we're talking to, it's in their strategic plan moving forward. And if it's not B, you've got G coming online, or some people are with 802.11a, we can adapt the system to accommodate any of those standards.
Okay, what's been your experience so far with the human element? How patients respond, how doctors learn to operate this way?
Yeah, so what happens typically is we show it to somebody, and the physician will go, "This is great. This will really be helpful to me becoming more efficient, but how will my patients respond?" That's always an initial question, and I think I can answer categorically. The patient response is incredibly positive. Johns Hopkins has done a study comparing patient response through physicians through the robot as opposed to directly in person. And the study showed, and it's now published in the Journal American College of Surgeons, that patients prefer interacting with their primary care physician this way as opposed to another attending in person. And you can understand why. As long as you feel like that this modality is appropriately allowing the personal interaction that the patient wants, then you're satisfied, and you would much rather speak with the physician who knows your case and has been with you through your whole process, as opposed to someone else who comes up and says, "Oh, I'm Dr. Jones's partner, and therefore I'm the one talking to you today."
Okay, now previously at Computer in Motion, your previous company, you worked
Yes.
essentially remote surgical techniques where a doctor in one place can operate somewhere else. How does that technology relate to this? And do you see some sort of grand integration where doctors will be able to both examine and operate on patients remotely?
Yeah, so in the previous company, Computer Motion, which is now part of a company called Intuitive Surgical, the idea of surgical robots, the enabling qualities of surgical robots are multifaceted. One of the key areas, which is actually the dominant reason for surgical robotics, is they enable the physician to be more adept or more dexterous. And so in that scenario, the physician is actually in the operating room with the patient, but using the surgical robot as a tool, as basically a computerized surgical instrument in order to enable the physician to do more, to perhaps sew more precisely or what have you. However, within the area, we did some experiments and some initial studies in this area of telesurgery and telementoring, where a physician from one place can help with a physician somewhere else, perhaps perform an operation. One of the things we did was a surgeon in New York City actually took out the gallbladder of a woman in France, and that's using robotics to project human perception and dexterity to a remote location. And that is a capability that surgical robotics enables, but that will be coming along slower in terms of the whole evolution and adoption of that, but there's a great deal of interest in it.
Okay. What about access to additional medical records while a physician is somewhere in his or her office or home, and they can interact with the patient, but they want to check the MRIs, the X-rays, the prescription history, and so on? How does your system allow for that?
Yeah, I'm glad you asked that question. And to put it in kind of the bigger context, we were just pictured on the cover of Business Week a couple of issues ago with the title "The Digital Hospital."
Right.
And so the whole idea is that patient information is all becoming digitized, and that's where these electronic medical records are gaining a lot of momentum, because all the lab reports, the MRI, CTs, progress notes, etc., are now digitized and allow a physician from anywhere to access that patient information. Now that couples very nicely with what we're doing with remote presence, because in a sense you can say we're digitizing the real-time patient interaction. So in our control station, which is where the physician sits when logged onto the robot, there's actually two screens. One projects the screen of what the robot sees and projects the physician into that remote environment. The other screen, though, pulls up the electronic medical record. So now the physician can not only interact with the patient in real time and make assessments and educate the patient, but he can also access all of the information from the medical record and therefore have more information at his fingertips to make the right decisions.
Now, does this serve as an impetus to hospitals to digitize their records and their other processes more rapidly?
I think it does. It's another compelling reason why hospitals should move towards these electronic medical records, which is actually a movement which is underway and with very strong backing already.
Would this almost mean that a physician sitting in his or her office with the patient across from him or her across the desk could almost have one of these in order to access the medical records more easily and talk to them that way? In other words, what are the further possible deployments of this within the structure of the practice of medicine?
Well, you see, the practice of medicine, and if you think of the whole healthcare system in totality, it's predicated on the concept that the physician and the patient have to be co-located in order to interact and advance that patient's care. And that's a significant restriction. As the patient's information all becomes digitized through the electronic medical record, and remote presence is helped. Looks like I log off here for a second.
Right.
But if those two things are now digitized, now the patient and the physician do not need to be co-located in order to advance care, and that allows a rethinking, a retooling of how the healthcare system should actually work.
Okay, now on that item, there was a big discussion I listened to on NPR yesterday, maybe it was the BBC, about the outsourcing or the offshoring of medical procedure tests and the reading of MRIs and the reading of X-rays, I guess, if they still do those, to India and China and so on, where a competent technician or doctor works for a tenth of what he or she works for in the United States. How does this tie in to both the outsourcing of medical technology readings and the delivery of healthcare? Is it creating what Tom Friedman's calling a flat hospital, so that there's really one big healthcare system for the whole world, and the resources are mobilized through that network?
Well, that's a good question, and I don't have that good a crystal ball to be able to articulate a concise answer there. However, the certain trends are very much in place. As you already said, the outsourcing of radiology reading to India and China is something very much in full swing right now, and it's going to be interesting how that plays out. Obviously, some of the challenges are the licensure issues, the board certification, who's got liability, and those types of things. Remote presence is a way of enabling, just like the internet's allowing people all over the world to chat and find each other much easier. Remote presence does allow a much more personal interaction that's been previously possible to happen where geographic boundaries are no longer a limitation. And I think that can impact the healthcare system on a global basis in both fronts. One is bringing in, enabling kind of lower cost labor this way. Additionally, it can actually bring U.S. expertise out to the rest of the world. I think in the world in an overall sense would agree that the U.S. has some of the leading medical capabilities of anywhere in the world, and has leading medical specialists. And to be able to deploy these people's capabilities into China or the Middle East or Europe or wherever is very attractive to many of these other countries.
Okay, two points, one pretty specific and one more general like that. With the application of remote effectors we've been talking about in terms of surgery, a lot of tests that are done on samples, biopsies, blood tests, other DNA calculations, those are done right now by local present workers using machinery. Is there any reason why those machines can't be operated by lower cost operators in other countries?
So the type of machinery you're referring to are medical devices, or I didn't catch that. I'm sorry.
Machines that are used to do blood tests or DNA calculations or biopsies. All of those procedures that are now done locally on inert parts of samples taken from patients. Can those also be, in addition to MRIs, which are digital information that can be shipped around, the tests can also be the manipulation that needs to be done of those machines can be operated remotely. In other words, if you can operate on someone orthoscopically, you can also run a blood testing machine from a remote location as well.
Well, I think the answer to that is yes. It's not an area we're currently pursuing, but I don't see a reason why that can't happen.
Okay, and let's focus, before we wrap up, on that globalization issue. Essentially, that it's creating a unified global market in medical services, so that MRI readers and neurosurgeons can be wherever the need is rapidly at a low cost, and therefore all of those calculations can be based on universal, ubiquitous access to those experts.
Yes, I mean the globalization of let's call it a flat healthcare system is probably going to be more limited by issues related to licensure and liability than it will be by technology. We have Hackensack Medical Center as a customer of ours, and one of our users wrote me an email, Dr. Garth Ballantyne, a few days ago, telling me he was in Korea at a society meeting.
Physically in Korea.
And he was physically in Korea. Hackensack is in New Jersey, and he wrote me that he rounded on his patients in New Jersey while he's in Korea. And he also wrote that he saw no perceived increase in latency going over the internet that far. Latency is important to us because, you know, it's a closed loop system. You drive the robot and you have to see it move in order to be able to drive it effectively and converse with patients. But from Korea, he rounded on patients in New Jersey, and he thought it was very effective.
And now, is his liability as a physician changed or limited in any sense that he's practicing in Korea for patients in New Jersey? How does we can't? I think another time maybe we can start talking about this. But just as a general first look,
I think he's running on his own patients, so he's liable for those patients. He's licensed, you know, in New Jersey, works for Hackensack, and so he's fully liable even if he didn't appear.
Right.
And so this is helpful with that. Alternatively, if it was a Korean physician who logged into Hackensack, then that's when the issues of liability and licensure really come into play.
So the big issue now really is, now that you've created the infrastructure for a global medical system, the lawyers and the legislators and the judges and those actors need now to bring the world's medical systems into accord with the technology that you've created.
Yeah, and so we're, in terms of our activities, you have that phrase, think globally, act locally.
Right.
You know, those dynamics, which you're saying, are much bigger than we're able to move on at this point in time. So we're focused on the areas of enabling physicians to be in more places at once, where the licensure and liability issues work in our favor, as opposed to trying to buck up against the system. But your point is very well taken in terms of what can ultimately happen with because of the combinations of technologies like what we have here, remote presence and electronic medical records and the internet, etc.
Okay, two last questions. I'm interviewing Dr. Martin at UCLA tomorrow. What's the status and function and importance of the test that's going on at the trial that's running at UCLA with your equipment right now that Dr. Martin's involved with?
Yeah, well, Dr. Martin, who's the chief of neurosurgery at UCLA, they have a robot in their neuro-intensive care unit, and he works with Dr. Paul Vespa, who is the director of that neuro ICU. And they are using the system to see if afternoon, evening rounds on the patients, which are the standard of care is actually by the phone today. By using the robot, they can pick up more information on the patient and make more proper diagnosis and recommendations on how to move therapy forward. And I think anecdotally, it's showing that will be very effective.
Okay, tell us just a little bit about the structure of InTouch Health. Is it privately held, publicly traded? What's the story on that?
InTouch is a 3.5-year-old startup. We're privately held, and I think things are going well for us currently.
Okay, well, I want to thank you for talking to us about it today from Santa Barbara to me in Los Angeles. Thanks to Juan there on the screen. Maybe we can end up by you can ask Juan to move the robot out so people can get a better look at it and get an idea that it's not just sitting there, but it also moves around.
Sure. Hey, Juan, can you move the robot around a bit? I think you might have to back up to see more of it.
Back up and out the door or something.
Just turn.
Right, there he goes. All right. Good.
Great.
All right, I want to thank you, and look forward to talking to you more in the future as this process and this technology leverages itself throughout the medical care space.
Thank you very much, Mark.